My name is Justin Turner, and this is my capstone project for predictive analytics. My area of expertise is marketing. That's what my bachelor's is in, and I want to get into marketing analytics whenever I finish my MBA program. So, to start out this project, I used the body fat Excel sheet, and what we want to do is predict body fat based on various other factors. And the first thing in order to do that, lines 2 and 3, we're going to upload it from Excel into our program. Line 5 is going to create the model. We're going to call it multivar model, and we're going to use LM for linear model. And we want to predict body fat. So that's going to go first, and then tangela. And then on the other side of the tangent, we have a dot, which means we want to use all of the other data points in order to try to predict body fat. And then our next argument in this function is the data that we're going to use. And we're going to use body measurements that we uploaded in line 3. And then after we make our model, we can summarize it. And that's going to give us a good idea of how much accuracy we have. We can assess our model from it. And one of the best ways to do so is with the p-values that it gives us, which is going to tell us how significant the values are to predicting body fat for each one of these things. And then we have our standard error. The lower standard error we have, the more accurate our model is. And what we can tell from these results is that density is a very good indicator on somebody's body fat. So in this next line here, I created another model that excludes density. So I did the dot and then I did minus density. So it's going to exclude density because all the time you may not have that goes so hand in hand with that, or you might want to exclude that because they're so similar in nature. And if we do that and run the summary on lines 9 and 10, we see that our model is much less accurate because we're not using one of our variables that has a very high correlation with the body fat variable. Next, I made a regression tree because body fat is not binomial. It's not, yes, somebody's fat, no, somebody's not fat. It's a number, so it's numeric, so it has to be a regression tree rather than a classification tree. So lines 21 and 22 are going to basically be installing, and 24 and 25 going to be installing the packages that we need to do to create and run this model. And then once again, we upload the body measurements in 27 and 28 in case that's on a different script. And then what we're doing here on 30, 31, 32 is going to be breaking it down into training data and testing data. So we use kind of this function right here, create data partition, body measurements, body fat, that tells which variable we're trying to predict. I did P 0.8, which is telling it we want 80% in one of them and 20 in the other. False is gonna leave our numbers as a vector, and then times is telling it how many times to split. So what we're telling it here is basically in 31, we're telling it to create the 80%. And then in 32, we're telling it to subtract that and use the rest. And then we use the R part function, same here. We want to use body fat and we want to use all other things to predict it. We're using our training data, and then method is going to be ANOVA because it is not binomial. And then our next line here is going to predict using our testing data, the data it's never seen before. And then what this is going to do is calculate how accurate it is with the math. It's gonna use this formula here to subtract and do the math, and the end result's going to tell us the accuracy, and we get the standard error at 1.9, so it is also a viable model. Next, we're going to look at the loan results. So we are going to make a classification tree because it is binomial. People either got their loan or they did not. So first thing we're going to do is upload the data. We're going to do the same thing and make testing and training data. Same as before, 80% false, 1. And then we're going to take it and it's going to make the 80% and then it's going to make the 20%. Then we're going to use our part to create the model, which is going to make the decision tree. So we want to use loan result, or we want to predict a loan result using all of the other variables. We want to use our training data, and method is going to be class because it is a classification problem. And then this next line will create the predictions on the data it's never seen before. And then we use this. It's going to use the math to tell us an accuracy percentage. And it's 74% accurate, which in this case, I believe is a viable model. And then made a logistic regression last. So our first line of code here is going to upload, and then it's going to make it a factor so it's going to basically tell it that it's binomial. It's going to create that training and evaluation data on 21 and 22. It's going to create the model using the GLM function, using the training data, and it's telling it it's binomial. And then it's going to predict on the evaluation data for 25, and then 26, it's going to basically tell it that anything above 0.5 is yes, anything below 0.5 is no. And then after that, it makes the matrix, which is going to tell us the accuracy. And we have 77% accuracy, which is a viable model.